Now, after you solve for all the angles, the next step is to try and solve for all the external forces, okay? All the external forces acting on a truss, all right? Because the external forces need to be in equilibrium, okay? All outside forces acting on this have to equal 0, all right? So we have 1,000 pushing down, 500 pushing down, and 250 pushing down, okay? So there needs to be a reaction force pushing up against these guys with the same total. All right? All the outside forces have to equal 0. Now the problem is this. For these ones right here, there's 2 unknowns. So we can't just say, okay, cut it in half and put some here and some here. It doesn't work. We still have to solve for it mathematically because it's not equal forces pushing out. We got 1,000 pushing here, only 500 here, and only 250 here. So the forces aren't going to be equally distributed amongst this truss, and we've got to try and figure that out. All right. One that we do know right away is that we're going to come back to here. The sum of all the forces. This is the sum of all the forces either in the x direction have to equal 0. The sum of all the forces in the y direction have to equal 0. Okay. So I always like to draw this guy in like this. And you'll see this a lot. And these are positive forces, and these are negative forces. So whatever way they're pointing, I can give them a positive or negative association. All right. Right off the get-go, this is the x direction is side to side, and y is up and down. All of these forces are pushing up or down. Okay. These ones have to be pushing up or down. These ones are pushing down. Okay, so we know that these have to be pushing up or down. But this guy over here is pushing side to side. He's in the x direction. If there's no other forces, then he has to be 0, just by the simple rule of the formula. Okay, like the formula stated, the sum of all the forces in the x direction has to equal 0. Well, if there's only one force, all right, this is the reaction force at pin A. Reaction force at A in the x direction plus, and there's nothing else to add it to, well, it's going to equal 0. All right? There's nothing there for it to push against. So this guy is 0. Okay? He's a nothing. These guys here, we can't just add up because there's 2 unknowns. Okay? We just don't know what they are. So in order to get rid of one of the unknowns, we're going to use this formula here of moment. Okay, using moment, we can get rid of one of these guys, all right, and just get down to one unknown, and we'll show you how that works. All right. The formula for moments is this: it's twofold. The sum of all the moments equals 0. Okay, the sum of all the moments equals 0. Well, what is a moment? Well, you find moment by multiplying the force times the perpendicular distance. You probably should have this little thing there for perpendicular distance from a given point. All right? So how are we going to do that? Well, we need to pick a point. And for us, we're going to pick this one right here, point A. All right? So there's point A. Now, we need to just start finding out what all of our moments are. Because remember, when we add them all up, they have to equal 0. All right? So the sum of all the moments equals 0. Well, what are our moments? Well, let's start with this one right here. Here's our pin. What is the perpendicular distance if the force is going up and down? What is the perpendicular distance to where that force is being applied? So if here's our point, you remember this was 3. So our force is negative because it's pointing down. Our force, well, I'll do this, moment equals force times distance. So for this guy, it's going to be, our force is negative 1,000, all right? And our distance is 3, okay? So 3 times negative 1,000. All right, that's our first one. What about our next one? Well, the distance from the pin to where the force is being applied, the perpendicular distance. So if the force is running up and down, what's the distance running this way? This is going to be 3, and then we remember this was 2, so it's going to be the total distance is 5. And what's our force? Negative 250. All right. Then we have this guy here. What's our distance? Well, from the pin, this was 3. Then we went 2 more. That takes us to 5. We take 2 more. Remember the perpendicular distance. So it's going to be, what's this length from here to here? Boom. That's going to be 7. And what's our force? Negative 500. Okay, it's pushing down. It's negative 500. All right. And then we have these two guys. All right. Now, like I said, when I said that we do the moment calculation, I said we were going to get rid of this one. I'll show you why here right now. What is the distance of this force from point A? It's 0. Okay. So the distance is 0. And what's the force? Well, we don't know, but we know it's the reaction force at A in the y direction. That's how we write that. Reaction force at pin A in the y direction. Okay? What about this guy here? Well, what's the distance from here to here? All the way across it, halfway was 5, the rest is, it's going to be 10. Okay? So our distance is 10. And what's our force? Well, we don't know, so we give it a name, and it's going to be the reaction force at C in the y direction. Okay? Reaction force, I'll move this over here. The reaction force at C in the y direction. Reaction force at C in the y direction, up and down. All right? So now, according to this formula right here, the sum, or when we add up all of these guys, once we calculate their moments, it should equal 0. Okay? So, let's do it. All right? What's 3 times a negative 1,000? It's going to be negative 3,000. 5 times negative 250. All right, we're going to be negative 125. 7 times negative 500 is negative 3,500. 0 times this unknown, well, anything times 0 equals 0, and that's how we get rid of this guy. Boop, 0. We just got rid of him. So the only unknown that's left is this, all right? So, and then we just say that this equals 10 times, because we can't solve it yet, the reaction force at C in the y direction, okay? So if I were to add these together, it should equal 0, all right? Well, let's add these guys together, and I'll do it here on my calculator. It's negative 3,000 plus negative 1,250 plus negative 3,500. So these guys together equal negative 7,750. Okay? So I'm going to rewrite this formula again, the sum of all the forces. Well, I added these 3 up. I could add 0. It's not going to do anything. So it's negative 7,750 plus, and then it's 10 times the reaction force at C in the y direction equals 0. Okay? Well, let's get this reaction force by itself. So we're going to add 775 to both sides, plus 775. These are going to cancel out. So 10 times the reaction force at C in the y direction equals 7,750. Well, how do you get the reaction force by itself? We're just doing simple algebra. We divide both sides by 10. And you're going to find out that the reaction force, that's going to cancel. All right, and then these zeros are going to cancel out here. You're left with 775. So this reaction force, the reaction force at C in the y direction is 775. It's positive 775. So which direction? Well, it's in the y direction, and it's positive, so it's going to be going up at 775. Okay? 775. Now we can use the sum of all the forces in the x direction, or excuse me, in the y direction, have to equal 0. Okay? Because we only have one unknown now, and we can solve for that last unknown. Okay? So let's rewrite our equation. The sum of all the forces in the y direction have to equal 0. Now we're talking about forces, not moments anymore, just straight up forces. So let's list all of our forces. Well, we have the reaction force at A in the y direction, so reaction force at A in the y direction, plus, okay, this guy's pointing down, plus, I'm going to write negative 1,000, plus negative 250, plus, we got negative 500 here, and I'm running out of room, plus, I can fit it in here, 775. 775. Okay, he's positive. Remember, he's going up. These guys are all going down, so they're all negatives. If it's going up, it's a positive. All right? If they're going up, it's positive. If they're going down, it's negative. Okay? So this, all of this should equal 0. When we add up all those, it should equal 0. Because it's got to be, all the external forces have to be in static equilibrium. All right? So let's hurry up and just, we'll combine these. Whenever you add negatives, it just makes a larger negative number. So we have reaction force at A in the y direction, all right? And then we have 1,000, 1,500, 1,750, okay? So plus negative 1,750 plus 775, all right? And we can actually combine these two numbers, okay? And I'll do it on my calculator for you to see here. Negative 1750 plus 775. What do we get? Negative 975. So reaction force at A in the y direction, okay? This is just this equation is simplified to this. We're going to simplify it even further to this. 975 equals 0. Well, how do you get this by itself? Add 975 to both sides. All right. This is going to cancel. So reaction force at Y, or reaction force at A, excuse me, in the Y direction, there we go, equals a positive 975. And we know positive is going up. So a positive up 975. All right. So now, we've solved all the angles, we've solved all the external forces. And this truss, all the external forces are in equilibrium. They're all accounted for, okay? There's a total of 1,750 pounds pushing down, and there's a total of 1,750 pounds pushing up, all right? And there's a total of 0 pushing side to side. This one's all by itself. There's no other forces, so therefore this must be 0, okay? From here, we are now going to move into free body diagrams, okay, which you will see here in the next video.